Welcome everybody. This is a question that is very prominent in the discussion forum. I thought I can provide my insights to this question. Now the solution is already available on the social media, but apparently there are a lot of arguments with regard to the solution provided by the professor. So I thought I will provide the air of clarification. So having mentioned that, let me start off with this question. This is question with regard to limits, and we are expected to find the function value when x is tending to infinity. Now the claim is they are saying, why not I simply let x to tend to infinity. This would mean 1 over 3x will tend to 0. This in turn would subsequently mean 1 positive 1 over 3x would be equal to 1. This in turn would mean 1 positive 1 over 3x raised to the power of x as x is tending to infinity will give me, this is going to be 1 raised to the power of infinity is equal to 1. This is the claim of the people in the forum. Majority are claiming this should be the answer, but apparently this is not the answer. Now let me explain to you why this cannot be the answer. Fair enough, x is moving towards infinity. Now we have a function. Now let me consider this function f of x to be equal to 1 positive 1 over 3x. Now imagine x tending to infinity to be in form of steps. Okay, you have stairs. Now the function has to climb these stairs. Now what people are telling us is that, okay, the function has reached the point. As x tends to infinity, this is going to be the point of the function. My question is, how do you know? This is the vital question that has to be answered. Just because you directly go to the end and state that x has reached infinity, so the function is going to be taking this value, that line of contention is inaccurate or ambiguous. We cannot do that. That is like stating like an individual who has become a CEO. Now, in real life scenario, what people see is this person becoming a CEO. Now what people do not know is what this man has done during the process of becoming the CEO, right? So that journey is what we are looking into. We want to know the journey taken by f of x. Now in this case, suppose if I were to take x to be a very large value, say for example 50,000 or 500,000. Now 1 divided by 3 times x will definitely be a small value, but this small value is added to 1 is not equal to 1. Have that in mind. So that is why we cannot outrightly state that as x is going towards infinity, we will have this quantity reduced to 1. That is a fallacy or ambiguous route to take. We cannot take that route. Why? Because there is a well-established fact. If the limit of say n tending to infinity of a certain function 1 positive 1 over n raised to the power of n, by calculus we have proved this to be equal to e. Okay, so this is a well-established result. Now having got this result, what we have to do is we have to actually either apply this result or apply the basic properties of L'Hopital rule to get the result. Now what does the L'Hopital rule state? The L'Hopital rule can only be applied if we are getting an indeterminate form. Now these are popular indeterminate forms, 0 by 0, infinity by infinity. Now what I'm going to do is I'm going to convert limit x tending to infinity of 1 positive 1 over 3x raised to the power of x to give us this 0 by 0 form. So for that, let me take the function to be, say, some u. Now u is equal to this, that means u is the limit, okay, u is the value provided by this quantity. Now I will take ln both sides. Now if you take ln both sides, on the left you get ln u is equal to ln of limit x tending to infinity of 1 positive 1 over 3x raised to the power of x. Okay, now I'm going to take the ln inside. Now you might be asking me, how can I do that? Yes, I can do that because of the fact that ln is a continuous function for all x greater than 0, and that alone is sufficient for me to push the ln inside and move the limit out. So that is the requirement, or I would say a postulate given by the limits. So ln comes in, so we got ln of 1 positive 1 over 3x raised to the power of x. Now from logarithm I know ln a raised to the power of b is equal to b times ln a. So this is going to be equal to limit x tending to infinity of x times ln of 1 positive 1 over 3x. Fair enough, right? Now can I rewrite this as limit x tending to infinity of ln of 1 positive 1 over 3x divided by 1 over x? If 1 over x flips, I get this quantity. Yes, of course I can write this. Now as x tends to infinity, 1 over x will tend to 0. So this is going to be producing me 0 by 0 form. Okay, fair enough. This is indeterminate form. Now having got this indeterminate form, I will apply the L'Hopital rule. Let me take a new page so that this question is always in the frame. So we are going to be applying L'Hopital rule. So what are the L'Hopital rule states? Differentiation of the numerator divided by the differentiation of the denominator, right? This is our L'Hopital rule. So I'm going to differentiate this quantity. So what is the differentiation of that? That is going to give me 1 over 1 positive 1 over 3x multiplied with the differentiation of 1 over 3x divided by the differentiation of 1 over x. Now let me show you what is the derivative of 1 over x. This is nothing but d of x raised to the power of negative 1. I differentiate, I get negative 1 x raised to the power of negative 1, which is nothing but negative 1 times x raised to the power of negative 2, which is nothing but negative 1 over x squared. This is what I get. So if I were to apply that, this is going to be 1 over 1 positive 1 over 3x. Differentiation of this is going to give me negative 1 over x squared divided by differentiation of this is negative 1 over x squared, right? So these two can be cancelled. So now what do I have? I got, okay, let me rewrite it like this. This is equal to 1 over 3 times 1 over 1 positive 1 over 3x. This is what I've got. Now on the left hand side, I have taken this to be a sum u. Okay, so that u should be there. In fact, over here you see that we take ln both sides. Okay, so on the left you got ln u. So you cannot forget that. So what happens here? As before I could go to the left, I'm going to apply limits. As x tends to infinity, 1 over x will tend to 0. So this would give me 1 over 3 times 1 over 1 positive 0, which is equal to 1 over 3. Now on the left I got ln u. So this means ln u is equal to 1 over 3, but this is to the base e. Now ln a to the base b is equal to y, then a is equal to b raised to the power of y. So by that property you get u is equal to e raised to the power of 1 over 3. But what is u? U is what? We took u to be as limit extending to infinity of 1 positive 1 over 3x raised to the power of x. So this means limit extending to infinity of 1 positive 1 over 3x raised to the power of x is equal to e raised to the power of 1 over 3. So that is the limit value. Thank you everybody. Please like, share and subscribe.